All right, welcome back, everybody. We're going to take two new shapes today, two new three-dimensional figures, and calculate their surface areas. We've already done the prism and the cylinder, and now we're going to do the surface areas of pyramids and cones. So let's get started. Let's take a look at first a cone kind of in more detail, or a pyramid, sorry, let's do a pyramid first. So here you see a pyramid on the left. That's a regular pyramid because the base is a regular polygon. And you see straight up from the center of the base up to the vertex is the height or the altitude of the pyramid. And then you have right here on the left side this blue line called the slant height, which is really the height of one of these triangles. Remember, a pyramid has triangles for its lateral faces. And this blue line, which is a height of one of those lateral faces or one of those triangles, is a slant height. This pyramid you see on the right is a non-regular pyramid. We're not going to do those this year. So just understand about the parts of a regular pyramid. Okay, let's do a calculation here. So we're going to calculate the surface area for a pyramid. So what you see here in this example is a square pyramid. We call it a square pyramid because the base is a square. So it's going to have four triangles on the sides, one for each edge of the base. And those four triangles are going to be congruent. So there's no real formula for this. You just kind of have to think about what parts make up that pyramid. So you know that's got a square, and the edge of that square is 5. And so to calculate the surface area, you're going to take the area of that square, which is 5 times 5 here, so 25. And then we're going to take 4 times the area of one of those lateral faces, one of those triangles, which remember is 1/2 times the base times height. So if you look at just the lateral face, one of those triangles, it's what 1/2 times its base, which is 5, times its height, which is 9. And remember that 9 is really the lateral, or I should say the slant height of the pyramid, but it's just the regular height of one of those triangles. So that those triangles are 1/2 times the base times height. So that's where you see 1/2 times 5 times 9 in the formula for the surface area. And then just add those numbers together and get 115 square inches for the surface area, total surface area of that pyramid. Okay, let's look at a cone in some more detail here. And figure out how to calculate its surface area. This is going to be more complicated. So if you look at the diagram there of the right cone on the left side there, right cone means that the height or the altitude of the cone is perpendicular to the base. So on the left, a cone, of course, we know has a base which is a circle. The altitude or the axis of the cone or the height is just a line perpendicular to the base, with one endpoint at the center of the base and the other endpoint at the vertex. And a cone has a slant height just like a pyramid does. The cone on the right is called an oblique cone, which is just a tilted over cone. We're not going to calculate those this year, so you can just concentrate on that cone on the left. Okay, the surface area calculation for the cone is rather difficult. Just for a fair warning here, but we'll try to get that through to you, and hope you understand a little bit. Let's see if I can make that smaller. Get that in there. Okay, so we're doing the surface area of a cone. Well, part of it's pretty easy. Part of a surface area of a cone is just the base, which is a circle. So that's pi r squared. The hard part is how do we get the surface area of the cone part? Like if you're eating an ice cream cone, it's the cone part. How do you get that? Well, you're going to have to use your imagination on this. So let's say we take this cone part, the upper part of the cone, and cut it down, just down from the vertex perpendicular, just cut it down and unroll it. So we're going to unroll that lateral surface here. And if you do, you see this shape on the right here, which looks like really a slice of pie or a slice of pizza. So now use your imagination. Again, if we just took the top part of that cone and unraveled it, flattened it out, its net would be this piece right here, this thing that looks like a piece of pizza. So the 2 pi r on the bottom of this little piece of pizza is going to be the radius of this circle. I'm sorry, the circumference of the circle. Circumference of this cone, the circle on the bottom of the cone, is going to be 2 pi r. So that's going to be this curvy part of the pizza slice. The slant height of this cone is just going to be like these two edges of the piece of pizza right here, these that I have marked L. Okay, now here's the hard part. So brace yourself here. So we're going to put that slice of pizza, which is, by the way, is called a sector of a circle. We're going to put that in a circle um, where this L right here, this used to be the slant height of that cone, is the radius of the circle. So we're taking this yellow piece right here and moving it into a circle, which you see down here. It says same. So we're going to put that into a circle where that sector of the circle, that slice of the pizza, is just inside the total circle. So we're going to set up a proportion where the area of the sector, so the yellow part here, divided by the area of the total circle, that's one fraction of the proportion, is going to be equal to just this piece, this 2 pi r, this piece of the sector, divided by the total circumference of the circle. So it's a proportion comparing the small yellow piece is its area with the area of a circle, and its little arc here, it's this curvy part of it with the circumference of the circle. Okay, so if we go with that proportion, we know that the area of this circle, I'm talking about the big circle now, is pi r squared. Well, the radius of the circle is L, so it's pi L squared. So again, this is the area of the circle. Form the first circle area pi r squared, but our radius is L here. So we made that substitution. Other side circumference of this circle is 2 pi times its radius. Well, its radius is L, so 2 pi L. So we get that proportion. Now, if you just look at the next line down, these 2 pi's are going to cancel. So just cancel the 2 pi's here. And you're going to get that right side, which is pi divided by L. Okay, now take that proportion right here and just multiply both sides by pi L squared. So it's gone on the left side. So again, what you're doing here is you're multiplying by pi L squared on both sides. And so the pi L squareds cancel on the left side, and on the right side, those L's cancel, one on top, one on bottom, when you multiply two fractions. So you just have pi times r times 1L. And that'll give you the area, that sector of that, which we call the sector here, that yellow piece right here, which is, remember, is a surface area, that lateral surface area of the cone. So that's your formula. And I told you that was hard, and it is. So that's a lateral area, just the cone part of the cone without the circle base. So long story short, the total surface area of the cone is pi r squared, which is for the base, the circle base, plus pi rl, pi times r times l, which is the cone part. So that'll be on a cheat sheet that I give you, so you'll have that available. Okay, well, it's easy to use the formula. It's, of course, a lot of times harder to prove it. So we're going to find the surface area of this cone right here. So we're given just the slant height is 3 meters and the radius is 2 meters. We're going to write down that formula that we're going to need. Surface area is pi r squared plus pi rl. So we got pi times 2 squared. The radius is 2, so pi times 4 or 4 pi. And then the surface area right there is pi times radius times slant height. The radius is 2, the slant height is 3. So it's going to give us a 6 pi there. So we're just going to take the 4 pi from the base, 6 pi from the lateral surface area, and get 10 pi square meters. We're going to leave that answer in terms of pi. So 10 pi square meters total surface area for that cone. Okay, let's do another cone. Look at this one. It says find the surface area of this cone. So if you look at that, you've got a right triangle sitting inside the cone where the one leg of that right triangle is the height of the cone. It's 12 feet. and the other leg of that right triangle sitting inside there is the radius of the cone. So we know that the formula for surface area of a cone requires that we know the slant height L. So we hopefully remember that 5, 12, and 13 are Pythagorean triples. Do you remember that? 5, 12, 13. If you remember that, you make quick work of this problem. If not, you're going to have to work out Pythagorean theorem to get that L. But 5 squared plus 12 squared equals 13 squared. So 13 is that L, that slant height, that we're going to be able to use for our formula for area of that cone. So slant height is pi r squared. We know the radius is 5, so pi times 5 squared plus pi times radius times slant height. And again, radius is 5. We just found slant height to be 13. I meant 13 there, not 3. Let's get that 13 in there. There we go. So we got 25 pi plus 65 pi gives 90 pi. So 90 pi square feet would be the total surface area of that cone. So really, again, it's just like we've seen pretty much all year, where you've got a formula, you just got to find the numbers for that formula, plug them in, and you'll be able to get the correct surface area or volume or whatever you're calculating. Okay, we're going to conclude today with a composite shape. Remember, we had composite shapes for two-dimensional figures. Now we have a composite shape for a three-dimensional figure. So we're going to calculate the total surface area. If you look at that shape, you got a cylinder on the bottom, and then you got a cone on the top. So we're given some of those dimensions there. So we look at the formula that we are going to have to work with here. So we're going to need pi r squared for the base of the cylinder. So we got the radius, we got 28, that's good. 2 pi rh, if you recall, that's going to be that lateral area of a cylinder, 2 pi rh. So we got the radius is 28 and the height is 45. So we got that. But then we need the surface area of that cone part, which is pi rl, which is what we just calculated. So we have all our numbers except for L. And so if you look at the top cone part, let's get that L by drawing in the right triangle that we all know about. So you can draw this height. And we know that's going to be 45 because the total height of that composite figure is 90. Take away that 45 from the cylinder. So we know that this part right here is 45. That's going to be the height of the cone. Okay, now we got the two legs of the cone. So we got 45 and 28. So we do Pythagorean theorem. We got 45 squared plus 28 squared equals L squared. We'll go through the calculations. You're going to find out that that slant height of that cone is for 53. So now we have all the numbers that we need for our formula to calculate surface area of this composite figure. So surface area again is pi r squared. We said the radius was 28, so pi times 28 squared. Now we'll do the cylinder body. So 2 pi radius slant, or 2 pi radius times height, 2 pi rh. That's for the lateral area of the cone there. And then the lateral area of the cylinder, the lateral area of the cone is pi times radius times slant height. So that's pi times radius, which is 28, times slant height, which is 53. We just calculated that. And do the math then. So the first term is 784 pi. Second term, 2,520 pi for the cylinder lateral area. And then the top part is 1,484 pi for the lateral area of that cone on top. Add them together, you're going to get total surface area of that composite figure to be 4,788 pi square centimeters. If they wanted that to be as a decimal, of course, we know what to do. You just have to put in 3.14 for pi. Okay, let's summarize what we did here today. We learned the surface area of two new shapes. We started out with the pyramid. And we said, really, for the pyramid, don't think of that as really as just a single formula because all the pyramids are different. Just think you got the regular base of that pyramid. You'd have to find that area and then add in all the areas of the congruent triangles for the lateral area, and then just add those all together for the surface area of the pyramid. And then we had the cone, which we saw was a little bit more difficult. The cone, remember, was circle base, so that's easy, pi r squared. And then the hard part was the side or the lateral area of the cone, which is pi times radius times slant height. So we derived that, and then we put all that together to find total area of the cone. And then we followed all that up with some examples, including the last one where we had a composite three-dimensional figure. All right, so let's get some practice with some of these areas.